Hi everyone, this is Unit 5. We are talking about graphing inequalities on a number line. Alright, so the first thing that we're going to look at is this is our number line right here, and the very thin line, that's supposed to be the number line, where it's darker, starting at -5, and then it's shaded to the right with this arrow. That just means that, if I draw this arrow a little bit bigger, it just means that that line would continue to be shaded forever to the right. So that shaded part is where our solutions are. So I'm going to say shaded is where solutions are. So when this says possible solutions, it just means what are some values that are shaded. And the thing that I noticed is that there are no numbers at all written on my number line. So you can have to kind of imagine the only number is -5, and -5 is shaded right here. So possible solution is -5. And then I have shaded every number to the right of -5. So you just have to think about any number that would be to the right of -5 on a number line. The very first number to the right would be -4. That means that's a solution. Now you can think of even though I don't have any numbers written here, you can imagine a number line. Any number to the right would be a solution. So if I went further to the right, there would be a number 0 over here. That's a solution. The number 1 is a solution. The number 10 is a solution. Any number that would appear in a number line to the right of -5 is a solution. So how we write our inequality is as simple as this point right here is our most important point, -5, right? And I know that I shaded to the right of -5, which means I shaded all of the values bigger or greater than -5. And I have to think about greater than. Is that okay? Greater than. Because I actually shaded in the value -5, which means -5 is included. So I really shaded greater than or equal to -5. And now I just put in front of this a variable, because what we're saying here is that x, so our number, our solutions, are any number greater or equal to -5. All of these numbers, if you plug them in for x, would make this inequality true. It says to write our inequality two ways, which just means that we talked about this in topic 2, I can rearrange the x and the -5. If I put the -5 first and the x second, my symbol would have to change, and I could read it like this. -5 is less than or equal to all of the values that I shaded. So -5 is less than or equal to x. Alright, let's try another one. So the next one we have this graph, and the biggest difference, I noticed a couple things. First, I noticed that I shaded left. Our last equation we shaded to the right, and this one we shaded all of the values to the left of 3. Let's think of some example values. This would be a 2, 1, 0, -1. You could continue that list, right? Those are all values to the left of 3 on a number line. Values to the right of 3, like 4 and 5, are not solutions because they're not shaded. Now something really special is happening here with the 3. It is an open, we call this an open circle. So in the other example that we looked at, we had a closed circle, right? Open circle means that the number 3 is not a solution. So we start to the left of -3 all the way up to 3, but not including 3. So possible solutions are -1, 0, 1, 2. And actually, I'm going to put this as a solution, 2.99. Imagine where 2.99 is. It's in between 2 and 3. It's very, very, very close to 3, but not exactly quite 3. That's a solution to this inequality. Alright, so our inequality two ways would be, since we shaded everything to the left of 3, I'm going to put less than 3. And I'm not going to put an equal underneath here because of my open circle. I'm going to put an x. This means x is less than 3. And then to write my inequality two ways, I could rearrange the 3 and the x, and also switch my symbol. Instead of pointing to the left, I could point it to the right, and this means 3 is more than x. 3 is greater than x. All right, let's look at another example. So in our next couple examples, we're asked to graph. So first example is x is less than or equal to 6. We are going to start by listing possible solutions. Possible solutions are any number that is less than or equal to 6. So let's think about 3 is less than or equal to 6. 0 is less than or equal to 6. 5, and what about 6 itself? 6 is less than or equal to 6. Let's write this another way. The other way that we could write this is we can rearrange the 6 and the x, and we can switch the symbol. So the symbol would be open to the 6. 6 is greater than or equal to x. And now we're going to graph. So when we graph this, we'll draw a number line. In the middle of our number line, I'm going to put our most important number, which is 6. Then we have to think about if 6 is going to be a shaded circle or an open circle. And in this case, it's going to be shaded because we are less than or equal to, because it's less than or equal to. And now we have to decide where we're shading, to the left or to the right. Now, think about where the numbers 3, 0, 5, and 6 are. Are they to the left or to the right of 6? Hopefully you said to the left, because 5 would be here, 4, 3 would be here. These are all to the left. So when we shade, we want to shade to the left of 6. So I usually have this shaded in, and then I just draw a line kind of above my number line to the left. And you can darken in that line if you want to. But that is so I start at 6 and I'm going to the left forever. All right, let's do one more example here. So in our next example, we are graphing 10 is less than x. And I'm going to jump ahead here and skip to the one that says write another way. If 10 is less than x, that means that if we rearrange x and 10, x is greater than 10. And I think it's a little bit easier to work with it when the x is on the left. X is greater than 10 means example solutions are 11, 12, 13, 20, 100. There's tons of numbers that are greater than 10. And when we graph, we'll graph our number line, we'll plot 10 in the middle, and then if you want to, you can think about where these numbers are. 11, 12, 13, 20, 100. So 11 would be here, 12 would be here. That's enough for me to realize that I am shading to the right. And so when I shade to the right, I'm going to first find 10, circle 10, and actually 10, we have to think about if we're shading in this circle or keeping it open. And in this case, since there is no line underneath, it's not greater than or equal to, we're not including the 10, we are just going to draw a line to the right without shading in. I'm going to draw my line to the right. I'm going to shade this in a little bit so it's really clear that that is my graph. Alright, that's it for topic 3. So you guys should be able to do homework number 1 with that information. Good luck.